Hello students, welcome back to Science Capsule, a perfect self-learning tool for school children. In today's video, we will be discussing about one of the most important topic from class 9 science, that is from the chapter the matter in our surrounding. What is that topic? It is latent heat. As far as latent heat is concerned, it is very important topic. When you go to higher classes also, there you will find, so if you learn the things here itself, then you will feel very easy when you go to higher classes. Now, in order to learn the latent heat, you should know some of the prerequisites, some of the basic concepts that has to be understood. So let us learn what are those concepts. Concepts such as melting point, atmospheric pressure, freezing point, all these should be understood. Let us see one by one. Now, when we talk about atmospheric pressure, we know that atmosphere is full of gases, right? And these gases exert pressure on the earth, or we can say that the gases have weight. When many layers of air are there in the atmosphere, when all these layers are on the surface of the earth and this air exerts pressure, the air has some sort of weight. When the weight is applied on the earth, then it exerts pressure, right? This is what we call it as atmospheric pressure. Simply we can say that the pressure exerted by the atmosphere on the earth is known as atmospheric pressure. Why should we learn about atmospheric pressure? We will see in the later section how the atmospheric pressure comes into play. The second thing what you need to understand is melting point. Dear students, in the previous section we have seen that matter can be interconvertible, right? So when we heat, solid changes into liquid, liquid changes into gases. On cooling, gases change into liquid, then further on solid. So we know that when temperature is increased, solid can change into liquid, but we don't know at what temperature solid changes into liquid, right? So melting point is the temperature at which the solid changes into liquid. Say for example water, the melting point of water is 0 degrees Celsius. Now when temperature is given to solid ice, then it changes into liquid when the temperature reaches 0 degrees Celsius. We know that when a matter is heated or liquid matter is heated, then it starts boiling, then vapors are coming out, right? So we can say that the temperature at which liquid changes into gas at atmospheric pressure is known as boiling point. And next we will see the freezing point. We know that on decreasing temperature liquid changes into solid. This process we call it as freezing. The temperature at which liquid changes into solid is known as the freezing point. So these are the basic skills required to understand about the latent heat. I hope you have the basic skills now. So let us start the latent heat. Before that, if you have not subscribed this channel, subscribe this channel and press bell icon so that you won't miss any of my future uploads. So let us start latent heat. You are very much familiar with heating any substance, right? Whenever you supply heat to a substance, normally we observe rise in temperature. This is what we have in our day-to-day experience. However, this is not so when a change of a state of a substance takes place. Here when we supply heat, this heat energy is used up in converting the state, that is either from solid to liquid or liquid to gas. This heat energy which is used up in changing the state is known as latent heat, and this latent heat does not rise the temperature. Now what actually happens about that we will see. When we heat a substance, then the substance gains the heat and gradually the temperature gets increased. Once it reaches the melting point, thereafter the temperature remains constant. Here after that, whatever the energy we supply, that energy is being used up in overcoming the intermolecular force of attraction, or we can say in breaking the strong intermolecular force of attraction which are there in solid. As a result of this, slowly the bond gets broken down and solid changes into liquid. Till all the solids are changed into the liquid particles, the temperature remains same. So the heat energy what we have supplied is hidden between the particles of liquid. This energy which has been hidden between the particles is called latent heat. Here latent means hidden. Now the latent heat is classified into two categories. One is latent heat of fusion and another one is latent heat of vaporization. Let us now understand both in detail. Let us understand latent heat of fusion and the latent heat of vaporization by this graph. Here the red line indicates the latent heat of fusion. Here this red line indicates latent heat of vaporization. Let us understand them in detail. We take water as an example to understand, because water can exist in all the three states, that is solid, liquid and gas, right? So this is our perfect example. Look at the graph here. The x-axis indicates energy input and here we are increasing the temperature. And also we know the arrangement of particles in case of solid, liquid and gases, right? We assume that this solid is ice. When we talk about ice, the particles are very tightly held and the intermolecular force of attraction is very, very large. Now when we are supplying heat, the heat energy is absorbed by the ice. As a result of this, the temperature goes on increasing linearly. Gradually, the temperature of the ice increases. When the temperature reaches 0 degrees Celsius, that is the melting point of ice, then it starts melting. So some of the particles of ice goes into liquid phase. Here we can see change in state. Now we are having ice at 0 degrees Celsius and the liquid so formed will also have same temperature, that is 0 degrees Celsius. And after that, whenever you supply heat energy, you will not see any rise in temperature. Here you can see the straight line. This straight line indicates that no rise in temperature. What happens to the temperature then? The supplied heat energy is used up in overcoming the intermolecular force of attraction, or we can say that the supplied heat energy is used up in breaking the strong intermolecular force of attraction. So we cannot see rise in temperature. The heat energy is suspended between the particles of liquid so formed as a result of melting or fusion. How long the temperature remains constant? Till all the particles of solid ice goes into liquid phase, the temperature will be 0 degrees Celsius only, and the heat energy available here is called latent heat of fusion. Since the heat energy is hidden between the particles, it is the temperature required to convert 1 kg of solid substance into liquid at its melting point is what we call latent heat of fusion. Here you can see very well that the ice is at solid state and water is at liquid state. Both are at 0 degrees Celsius. Now which one will be more effective in cooling? To understand this, we have to see the energy consideration. Here the liquid water at 0 degrees Celsius have hidden heat, that is latent heat. So we can say that liquid at 0 degrees Celsius have more energy as compared to the ice at 0 degrees Celsius. So solid ice at 0 degrees Celsius is more effective in cooling because it has less energy. Now once all the ice becomes liquid, thereafter the supplied heat energy increases the temperature. So thereafter we can see rise in temperature. Gradually the temperature increases. Once the temperature of the liquid goes into 100 degrees Celsius, we know that 100 degrees Celsius is the boiling point of water. At this point of temperature, once again you can see no rise in temperature. Here the state change take place. Here 100 degrees is the boiling point. Boiling point means the change of state from liquid to gas. Here the water becomes vapor. Now here rise in temperature we could not see. This is because the supplied heat energy is absorbed for converting the state from liquid to gas, or we can say that the heat energy is consumed to overcome the intermolecular force of attraction that are held between the particles of liquid, and the heat energy is trapped between the spaces available in the steam or vapor in case of water. Once all the liquid molecules go into gaseous phase, once again you can see the increase in temperature. Thereafter we can see that temperature gets increased. So the latent heat of vaporization can be defined as the amount of heat energy required in joules to convert 1 kg of liquid into its vapor at its boiling point. Now you can see very well that at 100 degrees Celsius water exists at liquid state. At the same time water can exist in gaseous phase, that is steam we say in our case. Now which one will cause more severe burn? liquid water at 100 degrees Celsius or steam with 100 degrees Celsius. Here we have to find which phase has more energy. Between the particles of steam, it has latent heat of vaporization. So steam has more energy as compared to liquid at 100 degrees Celsius. So steam causes more severe burn.